Foundation models are definitely a hot topic. They're called this because they provide the foundation from which you can perform a lot of different tasks or solve a lot of different problems. And this is really why they're such a hot topic. So, in short, foundation models are typically just really big models trained with a lot of data. And because they're trained on so much data and meant to enable a variety of downstream tasks, they're typically trained in an unsupervised fashion. So, in other words, they're trained to do something that doesn't require a human to sit there and label the data.
Welcome to the People of Pathology podcast. I'm Dennis Strink. On this podcast, we explore pathology, laboratory medicine, and forensic science. Foundation models are a type of AI that can perform a wide range of tasks after being trained on large amounts of data. These models are now being applied in pathology and life sciences. My guest today is Julianna Ianni from Proscia. In this episode, we're going to discuss her work with foundation models, and we get into Concentriq Embeddings, which uses foundation models for analyzing pathology images. All right, get ready for a crash course in foundation models with Julianna Ianni. Let's start with you and kind of your background. I like to get a little bit of context to where people are coming from. So I know you have a background in biomedical engineering, biomedical imaging. So tell me about this. How'd you get started in these areas?
Yeah. So I had kind of always been fascinated by anything in the biomedical arena since basically I was in high school. And that drove me to pursue biomedical engineering, just having a general desire to help people in that way. But early in my undergraduate degree, I had the opportunity for an internship in bioinformatics. And while it wasn't a fun one in other ways, it really opened up my eyes. So I was kind of just amazed at the power of statistical inference. And what I was yet to learn was essentially just machine learning. And I also took home the message that data is really powerful. And of course, the more the better. So naturally, I gravitated to the domain with the most data I could imagine, which was medical imaging. So I just threw myself into that when I pursued my PhD at Vanderbilt University in biomedical engineering, and I specialized in MRI. My graduate research was basically in finding ways to yield faster and better MRI images, as well as developing machine learning methods to tailor RF pulse parameters to specific patients. So to make high field imaging faster and safer. But while I was doing my PhD, I was listening to podcasts on applications of deep learning, and I realized there was a lot more potential than what I or anybody I knew was doing with it at the time. And so I was really eager to get on board that ship and pursue a career in that before it took off. And that's when I found the folks at Proscia who were applying deep learning to pathology. And I was just really excited about where they were headed and the possibilities of applying AI in digital pathology. And, now, of course, now the possibilities were even bigger than what I imagined then.
That's interesting that you kind of came from sort of a radiology focus into pathology because as I've learned over the years, there is quite a bit of overlap there, especially when you're talking about digital radiology and digital pathology.
Yeah, yeah, there is quite a bit of overlap. Radiology is often a bit ahead, but I guess at the time that I was trying to dive in, I was actually, having trouble finding folks that were using deep learning for MRI. And so that's what excited me about Proscia.
So that's you were like right at the beginning of this, which kind of has exploded since then as
Yeah,
far as applying deep
absolutely. Yeah,
learning.
there's no shortage of people doing that now.
Yeah, right. So that must have been exciting at the time to be right at the beginning of it, right?
Yeah, it was definitely exciting. Also a bit frustrating with the MRI part. I was going to the biggest conferences and finding like 3 posters that were were doing anything in deep learning. And I was like, guys, this is taking off everywhere else. What's going on? Yeah, but very, very exciting, definitely, to be kind of joining the field at that time.
So now you're the VP of AI research and development at Proscia. And so what does that mean? What are your like main responsibilities in this role?
Sure. I lead the AI R&D team at Proscia. So I'm responsible for leading the development of robust AI applications that both kind of operate through and enhance Proscia's Concentriq platform. And also, I'm driving innovation in these areas. So a lot of collaboration with other teams and communication of both the work we're doing today and what's possible tomorrow.
Okay, I see. Is it mostly like your sort of interaction is kind of with other people at ProShare, or do you I guess how much do you interact, like, with the customers?
Yeah, a good bit, and kind of it's, kind of comes and goes with what we're doing in the on the product side. So a lot more recently with the release of Concentriq Embeddings. But yeah, it's a bit of both.
Now, one the probably the main thing we're gonna talk about today is foundation models, and this has become, a again, another hot topic, and, this might be a little difficult to do in kind of an audio only format, but can we give sort of an overview of what are foundation models? What does this mean?
Yeah, yeah, it's a little more difficult in the audio format, but not terribly so.
Okay.
So yeah, foundation models are definitely a hot topic. They're called this because they provide the foundation from which you can perform a lot of different tasks or solve a lot of different problems. And this is really why they're such a hot topic. So, in short, foundation models are typically just really big models trained with a lot of data. And because they're trained on so much data and meant to enable a variety of downstream tasks, they're typically trained in an unsupervised fashion. So, in other words, they're trained to do something that doesn't require a human to sit there and label the data. So often, these models are just blinded to some piece of data that is associated with the input and trained to predict the portion that they were blinded to. So for text, that can be predicting the next word. For images, that can be predicting a blocked out portion of the image, etc. And so as I just kind of alluded to, there's a couple common types of foundation models. And you hear the word foundation model a lot in association with generative AI because there's a large degree of overlap. But I like to emphasize that foundation models are not equal to generative AI. So large language models or LLMs are foundation models, and many of their applications use them in a generative fashion. They generate a novel string of text in response to some text. So that's also the case for some of the image creation models out there that have been popular, like DALI. So this is another foundation model and an example of generative AI as it generates novel images. But foundation models can also be used in powerful ways for tasks that are not generative in nature. So one example of this is using them to derive embeddings for input images. So embeddings are a way of representing the features of the image in a really condensed manner. You can think of them like an information rich compression. And this is all represented by just a series of numbers that's called a vector. So the numbers would be totally meaningless to you and I, but they are incredibly meaningful to trained models. And that's part of what makes them powerful. And they can also be used for simply for basic data analysis, like clustering or grouping images into categories of other images that are alike. They can be used as an input to supervised machine learning models that now can be a lot simpler and require a lot less data to train because their embedding input already contains a lot of highly organized information from these foundation models.
Okay, so let me try to sort of restate what you just said. Like, so the foundation model is kind of the basic knowledge, I guess, or basic data, and then you can apply that to more specific problems.
Yeah, yeah, definitely. So it's a really large model, and the way that we kind of did things before was every model that we wanted to train, we would go gather a lot of training data. We would build like a deep learning model or a neural network specifically for that task. And it would perform well only for that task, if you did it right. And whereas now we're kind of taking a big chunk of that work with foundation models and say, okay, like all these models are really doing to begin with is creating features. They're figuring out what the real information in the images is in some abstract form. They're figuring out, okay, what do the cells look like? You know, what do the colors look like? All of these kind of bits of information. That's what all these models are figuring out. And we don't have to do that every single time we want to train a model. We can have just one big model that does that part. And then all these downstream models can just take those features and actually do what we're trying to do when we're building any specific model.
Okay, so we're talking about increased efficiency, time saving, basically, right?
To a large degree, yeah. Yeah.
Okay, okay. Getting back to the embeddings aspect, and you said this is extracting features from the data, right?
Yes.
Like, for example, applied to pathology slides. What sort of features are we talking about here?
Yeah. So, like I said, it's not, and probably not going to be anything that you would go, oh, this number means exactly this. Although there are some papers that try to figure out what the black box is doing in terms of that.
Okay,
But it really is kind of a black box that's still figuring out a lot of information about the images. So it could be, what are the shapes of the cells? What are the sizes of the cells? What is the kind of context of those cells, and that sort of thing. But it's not trained to do that, and so it's not explicitly doing that. It's what it's explicitly doing is kind of learning to replicate regions of an image based on what it typically sees when it sees certain surroundings. So it's a really foreign to us way to learn, and the features that it learns are probably a little foreign. But when you get down to it, those are the kinds of things that it's learning.
okay, I got it. All right. So Proscia recently announced concentric embeddings. So let's talk about this. First of all, what is this? And then how are foundation models used here?
Yeah. So before we embarked on concentric embeddings, we just took a look at the state of the field and the pace of innovation and then that our users have. And I think we really understand a lot of those needs well because we develop AI applications too. So we know what the pain points are. And the worst pain points were not that models were not accurate enough for many applications. The worst pain points were just in using those models, difficulties using those models. So you would run into things like variety in image formats. Nothing is really standardized. Struggles just gathering and downloading the data that you need because full site images are so huge. Infrastructure challenges, where are you running this? You have GPUs, etc. MLOps challenges, just kind of building these machine learning pipelines and just all kind of things like that. And so all of this represents the vast majority of the work actually that data scientists and researchers spend doing model development. A lot of their time is spent just solving some like really basic problems, except they're not so basic. They take a lot of time to solve. So concentric embeddings is an answer to that. It abstracts away all of these issues and just basically hands users what they want to start building from, which is those clean embeddings, those clean features. How it works is just that users make an API call to concentric embeddings. So they basically just ask for embeddings from whatever set of images they like at whatever image resolution is relevant to their problem. And they can select from a host of foundation models that we have. And then they get back embeddings that they requested that are just ready to use for their downstream use case, which is typically training a simpler model.
So the researcher is working on a particular type of image or a type of tissue slide, whatever. And so you're taking away all of the collecting the data analyzing the data. You've already got all of that, and you just say, "Here you go. Here's your embeddings."
Yeah, so typically our users would already have some data in our platform
Okay.
and yeah, so it's once they have that, it's really easy for them to
Uh-huh.
just get the embeddings out.
Okay. This is gonna be kind of a weird question, but, like, did somebody come in one day and go, "Hey, I was reading about foundation models, and we should try this." Like
Mhm.
what was that sort of, I'd like to call it, like, the light bulb moment, and you went, "Oh, yeah, that's a great idea." You know what I mean? Did that kinda thing happen?
Yeah, I wish I knew a straight answer to that. No, I know, actually years ago we were talking about how hard it was for us to just get pixels out of our platform to build these models. So not embeddings, but just, you know, image patches.
Okay.
And so I think a lot of the thinking came out of that because what we were doing with those image patches was basically immediately trying to turn them into feature vectors, into embeddings. Now that was kind of that sort of conversation, that seed was prior to all these foundation models coming out. And so that definitely wasn't when we started working on this. But I think just seeing, over the past year, 2 years, we've had these foundation models coming out and it's just felt like a surge of activity in this domain. And that's when things clicked for me that like, wow, something really big is happening here and we need to do something about it. And uh, this just made the most sense to me instead of chasing after, okay, let's build a foundation model that has like 2% higher accuracy, which is really, really tough to do. I don't mean to diminish that
Mm.
work, but it just this made the most sense from in terms of what 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 expertise can Proscia provide and the strength that we has here is our platform and we have users with data already on the platform. So how could we help users use these foundation models?
This is the People of Pathology podcast with our guest, Julianna Ianni from Proscia. We'll be right back. LabVine is an interactive online learning platform where laboratory professionals learn, develop, and discover by sharing knowledge and building on each other's experience. The platform provides global access to internationally accredited laboratory specific courses and other resources developed by lab specialists like us for the laboratory industry. LabVine is free to sign up, and you can use the link in the show notes to get started. If you think it would be nice to have a helpful reference about digital pathology, I have some great news for you. Dr. Alexander Zhurov has written a book called Digital Pathology 101. All you need to know to start and continue your digital pathology journey. This book will help you whether you're a complete novice or a digital pathology trailblazer. You can get a copy of it by following the link in the show notes. Now for the rest of my conversation with Julianna Ianni on the People of Pathology podcast. It's funny you mentioned that, you realized something really big was happening with the foundation, and this is the second time this has happened to you, coming from radiology first and realizing,
Mm.
the importance of medical imaging, and now with foundation models.
Yeah, yeah, it's true. I haven't connected those two. But yeah, yeah, at some point you gotta and I don't know. I don't think I was maybe I was early with concentric embeddings. I don't think I was early with the surge of foundation models. I think I was actually maybe a little late compared to my peers. but but yeah, you got to pay attention when something's going on like this.
Yeah, for sure, and I think you're right. This is the more that I learn about it, which is, I'm like a kindergartner compared to what you know, but you're right. There is something really big happening, and it's interesting, but also I think useful.
Yeah, yeah,
Yeah.
definitely. I think Chat GPT was also kind of like a big flag to me. I'd been kind of ignoring what was happening in
Uh-huh.
the language domain for a while before that. Bert was out and I wasn't really impressed. Like, just couldn't do what you could do with ChatGPT now. And like, there's a certain threshold of accuracy I think that you need for a lot of applications. And ChatGPT kind of hit that. And I was like, oh, both things are happening faster than I thought.
Mhm. Mhm. Yeah. I think I know what you mean.
Yeah.
So getting back to concentric embeddings, let's talk about some of sort of applications of it. Like, what about for something like drug development? Are there advantages to using this?
Yeah. So I guess backing up a little bit, AI is already used at pretty much every phase of drug development
Uh,
and many of the applications that AI in general are also places where concentric embeddings can be used. So one example is for things like tumor detection using a foundation model. It's really easy to get embeddings and then train a simple downstream model to do that at a patch level. And then anomaly detection, similarly, is also a possibility for like tox path, where you really don't care about all the normal tissue, but the abnormal stuff is what you really want to get to first. And then you can use concentric embeddings to develop models to research identifying potential candidates for a particular drug or to identify biomarkers that might be associated with positive treatment outcomes. There are just more ways to use this than we can count at this point.
and the things that you're doing with this, it does them faster, more efficiently, right?
Yeah. Yeah, a lot faster. We did an internal study where we basically took our old workflow using, kind of an on-prem GPU workstation versus using concentric embeddings. And we grabbed the Impress data set and we're detecting biomarkers of that, predicting breast cancer biomarkers. And we were able to do this 13 times faster with concentric embeddings than we could doing it the old way. And we think like this data set is kind of undersized compared to a lot that are out there. And so we believe you'd see an even greater impact with more typically sized data sets.
That's a really significant increase.
Yeah, it's huge.
Yeah.
It's really huge. And but yeah, we're pretty sure we're kind of lowballing that with this
Mm,
data set.
okay. Okay. Wow. Interesting. I heard somewhere that AI algorithms, they're only as good as the data that they're trained on. And I imagine the same would be true for something like foundation models, not only for the amount of data that you're using, but also the diversity of the data. Does that make sense? Like, what do you think about that?
Yeah, I totally agree with that. And in fact, there was a study out of a German collaboration a few months ago, which concluded that data diversity in these models was actually more important than data set size. And that I think kind of goes along with everything else we know about machine learning at this point. If you train on a data set lacking diversity, your model will just not perform well on data that looks a bit different. But of course, it's best to have kind of the best of both worlds, the diversity and the large data set size when you can. But I think we're going to kind of continue to see a lot of growth in both those dimensions in terms of these foundation models that are out there.
That makes sense. How would you, because I know data it's anonymous. Are there ways to increase diversity of data? How do you do that?
Yeah, it's anonymous. I guess I should describe what we're talking about when we think about diversity in terms of training machine learning models in pathology. So there are so many factors that can go into that. It's not usually about like patient identity, although that could be a factor. Typically it's the site where they came from. So, they came from this lab or this hospital, or where did they come from? Where did the samples come from? You want as much diversity in that as possible. You want as much diversity in stain as possible. So there can be stain variations that throw models off.
Oh, okay.
You want diversity in like organ type, tissue type, that sort of thing. Even things like tumor type, maybe. So yeah, a lot of different factors, basically any difference that you can think of between that you might see between images, between pathology samples you want to sample for, and kind of the more differences in your data, the better.
Okay. Okay. I see. Now, have you been getting any sort of feedback from users of concentric embeddings? I mean, I know it's only been out for just a couple of weeks, but what have people been saying about it?
Yeah. So we actually have received a lot of positive feedback, especially as we had a few users trial Concentriq Embeddings prior to releasing it. So they're definitely all enthusiastic that it would bring them just enormous efficiency gains in terms of their AI model development. And they're finding that it's something that they can use for the vast majority of models that they build, which is important. So it's really the bulk of time spent developing otherwise, dealing with all those challenges I mentioned. And Concentric Embeddings just solves a lot of that for you. That kind of enables users to focus on building their downstream models, which is the part that really often requires some creativity and problem solving.
Okay. Okay. So it sounds like mostly positive feedback.
Mhm.
Yeah.
Yeah.
That's got to feel good to get to put this project out there and then get that positive feedback.
Yeah, definitely. I think we all internally, thought this was kind of a groundbreaking thing, but it's really great to and validating to hear that from your users, from your customers too. Yeah.
Sure. Sure. Now, this project is heavily influenced by collaboration with other companies. I mean, even in fact, some of the foundation models are not made by Proscia. There's some other companies involved.
Yeah.
And this seems to be with the number of people that I've interviewed from Proscia, this is kind of a theme with your company. Why is it important to do it this way? And kind of what are the advantages of this kind of collaboration?
Yeah, it's definitely a theme for Proscia. We understand that our users are trying to build and do a lot of different things, and there are just myriad applications out there. So, and I think the number of applications out there a year from now is going to kind of dwarf what's out there now. And to put it simply, these organizations just can't afford to be limited to one AI solution because that one solution is not going to solve all their problems, right? There are always more. So we want to be as much as possible a one-stop shop for AI. And that requires a lot of collaboration with those developing these AI applications. And concentric embeddings is not an exception to that. In fact, we haven't developed any of the foundation models available on concentric embeddings. They were all developed by others. And these foundation models are evolving really quickly. So what's out there today is not going to be state of the art tomorrow. So it's just important for our catalog to evolve to include additional models. For example, we just added BioOptimus's H Optimus Zero model less than a month after our initial launch. We also see that it's going to be important for our users to have a variety of models to select from because the best model for a particular application is probably going to vary by application. And there have been a lot of applications out there that emphasize the benefits of ensembling embeddings from different models, improving downstream model performance. So basically, the more models you have access to, the better.
Okay. I like what you said. This is kind of the one-stop shop place. I mean, the term I've heard before, the best of breed. Like you're
Uh-huh.
collecting all of the best things in one place, and then customers can pick what works best for them, right?
Right. Yeah.
And again, this has got to be increasing efficiency, saving time.
Yeah. Yeah. So, it definitely is going to slow folks down if they don't have access to the model that they need for a particular application. What do you do then?
Right. As much as I've been trying to learn about foundation models, this seems like the realm of computer scientists, IT, things like that, rather than pathologists and kind of, general science researchers. But how could someone who is not a computer scientist, a pathologist, or a researcher gain a better understanding of foundation models?
Yeah, concentric embeddings is definitely geared toward data scientists and researchers who at least
Hmm.
have maybe like a data science or a machine learning 101 level understanding.
Uh-huh.
Um, so it's a low barrier for entry compared to what's out there now. But yeah, not targeted at a pathologist at the moment. I think there's a lot of ways pathologists can learn. One thing I'd suggest is actually going on our website we've written a ton of blog posts and examples of how you use these models. And I will warn you, there is example code in the mix.
Hmm.
But you don't need to understand the code to get something out of these examples. You could skip over that part and still see some basic examples of what's possible with concentric embeddings, and with very little additional work. And then, of course, with more work, these models can do a lot more. We also have on our website a webinar recording we just did with Bioptimus, where Zelda Marie did a fantastic job, I think, explaining what these models are and what they can do. So I definitely recommend checking that out. I don't know that I can recommend other resources specifically for pathologists, but there is a lot out there. If you just kind of Google foundation models pathology, I'd recommend maybe just skimming through some of the papers. You don't need to
Hmm.
necessarily understand all the methods, but just take a look through the use cases they present and you'll start to get an idea of what's possible.
Hmm. Yeah, I did watch that webinar that you mentioned, and it is really good. There's a lot of good information there. I think it seems like the idea is maybe to become familiar with what foundation models are and kind of their, like you said, their use cases, because this is going to have an impact on pathology as a field. And
Yeah.
so, don't ignore it, I guess is the lesson, right?
Yeah, absolutely. Don't ignore it. I think that, from a pathologist perspective, probably what you're just going to end up seeing is that, you're seeing more and more AI applications pop up that
Yeah.
diagnostics. These huge efficiency gains are happening for the folks that are building these applications. Even if you're not the one building them, you're just going to see a lot more of them. So understanding kind of the basis for them is helpful.
Okay. Okay. I like that. Now, then looking towards the future, and this is going to be just pure speculation, right? What advances would you foresee with foundation models with regard to pathology? Like in an ideal world where if this field advances, like it seems like it's going to, how
Mhm.
far does this technology go?
Yeah. Yeah. I think, pretty far. I definitely can't see that far into the future, but I think it's multimodal. So right now, even just using a vision model to generate embeddings with concentric embeddings, you can do a lot in terms of building downstream models and downstream models that combine knowledge from different modalities. So say image and genomic data, for example. But when we think about natively multimodal foundation models, that means models which can embed more than one modality in the same space so that the two sort of speak the same language. It's really almost mind blowing what's possible. So Concentric Embeddings already supports one multimodal model. It's a pathology vision language model called PLIP, and it can embed images and text in the same space. So that allows some really cool things. For example, text-based image search. I type in text and I get, you know, some image pops up that corresponds to that text that typed in. But I think there's going to be some really groundbreaking applications when we start getting pathology models that combine not just image and text, but genomic data, proteomic data, perhaps treatment response and things like that. So to me, it's kind of hard to imagine what's possible when all these modalities get combined and they all speak our language.
That's interesting. Just like that's one of those things. Like if you sit down and really think about the possibilities, yeah, they are sort of endless, which is exciting, I think.
Definitely exciting. Yeah.
Yeah.
Hard for me to fathom right now.
Hmm. Hmm. I can understand that. Well, I guess a little bit. Uh, okay. Juliana, this has been fascinating conversation. I'm going to include some of the resources you mentioned in the show notes so that people can learn more about foundation models and learn more about Proscia and concentric embeddings. So, Julianna Ianni, thank you very much.
Thank you.
If you're looking for another episode of the People of Pathology podcast to check out after this one, here's a clip from my interview with Casey Wall as we talk about how Concentriq integrates AI applications into the platform.
Some of those can be solved with process automation solutions like automated QC
Okay.
that automate manual, tedious routine tasks. Others benefit from new insights that AI applications are able to unlock. We see the impact of these when it comes to biomarker identification solutions like PDL1 and many of the diagnostic aids that exist today. And we also recognize that no one company is going to build them all. Our vision is that research organizations and laboratories are leveraging a broad portfolio of AI applications, some developed by vendors like Proscia, and others that they develop themselves, in routine operations to recognize the full impact. That's why our Concentriq platform, which powers routine operations, is designed to incorporate AI applications developed by Proscia, other third parties, and our customers.
You can hear more from Casey Wall in episode 166. Wow. Big thanks to Julianna Ianni. Lots of high-level information there. My brain hurts a little bit. But this is a very interesting topic. Like we said in the interview, foundation models have become a hot topic lately. These models provide a framework upon which more specialized applications can be built. The discussion surrounding foundation models not only highlights their technical attributes, but also underscores their potential to revolutionize fields such as healthcare, particularly in areas like digital pathology and medical imaging. Foundation models are large-scale models trained on vast amounts of data, enabling them to serve as a robust base for solving a variety of tasks without the need for extensive human intervention in the data labeling process. This capability not only streamlines the development process, but also allows for the transfer of knowledge across different domains, making foundation models a critical component in the advancement of AI technologies. At the core of foundation models is the concept of pre-training on vast amounts of data. This pre-training phase allows the model to learn a wide array of patterns within the data, equipping them with a foundational understanding that can be fine-tuned for specific tasks. Foundation models are designed to learn from unstructured data in an unsupervised manner. This means that they can extract meaningful patterns and features from data and images without requiring explicit labels. For instance, in the context of text, a foundation model might predict the next word in a sentence, while in image processing, it could predict a blocked out section of an image. This ability to learn from vast data sets enables foundation models to create rich embeddings. These embeddings are compressed representations of data that capture essential features. Embeddings serve as a foundation for downstream tasks, allowing simpler models to leverage the complex information encoded within them. The role of foundation models in driving innovation cannot be overstated. Julianna's position as the Vice President of AI Research and Development at Proscia involves leading a team focused on developing AI applications that enhance the company's Concentriq platform. The integration of foundation models into existing platforms allows for the development of applications that are not only more accurate, but also more efficient, ultimately benefiting both data scientists and patients. One of the most significant advantages of foundation models is their efficiency in task execution. Traditionally, developing AI models for specific tasks required gathering extensive data sets and training dedicated models for each task. This process was not only time-consuming, but also resource-intensive. Now, with foundation models, the need for this repetitive cycle is significantly reduced. Instead of starting from scratch, researchers can utilize pre-trained models to extract relevant features, allowing them to focus on the more specific aspects of the tasks. So, in practical applications such as digital pathology, the benefits of foundation models are particularly pronounced. When applied to pathology slides, foundation models can extract various features, such as cellular structures, color distributions, and architectural patterns. By representing these features as embeddings, researchers can utilize them for tasks such as classifying images, detecting anomalies, and even predicting patient outcomes. The ability to harness the power of foundation models in this manner not only improves accuracy, but also saves valuable time for researchers who can now rely on AI-enhanced insights rather than manual analysis. The innovation of Concentriq Embeddings lies in its user-friendly approach. It allows users to make simple API calls for embeddings from their chosen set of images. Users can select a variety of foundation models which have been pre-trained on vast datasets. Julianna mentioned H-Optimus 0 in particular, but there are others. The number of available foundation models is expected to grow as well. This not only accelerates the pace of research, but also democratizes access to advanced AI capabilities, enabling more scientists to leverage sophisticated models without needing extensive technical expertise. As we discussed, there are a number of important use cases for foundation models. Drug development and biomarker discovery are two that Julianna mentioned. As this technology advances, we can expect to see many more. By using concentric embeddings, researchers were able to process data 13 times faster than traditional methods, showcasing not only the efficiency of the approach, but also its potential to handle complex, diverse data sets effectively. Collaboration is another vital area in enhancing AI efficiency. Concentric Embeddings is rooted in partnerships with other companies. Proscia recognizes that the complexity of AI applications necessitates a diverse toolkit rather than a one-size-fits-all solution. By collaborating with various organizations, Proscia can offer users access to a wide array of foundation models, each tailored to a specific application. This also increases efficiency since you don't have to start from zero every time. Lastly, as with any new technology, there is a learning curve. As Julianna and I discussed, foundation models are part of the realm of data scientists, not pathologists. And let's be honest, there's enough in pathology to keep up with already. But I think it's important to have a basic understanding of how this works. And that's true with advancements in AI, large language models, and digital pathology that we have discussed in other episodes. To be clear, you do not have to be an expert on foundation models, but I think you should be familiar with them. This technology, and others like it, is not going away. Foundation models have the potential to increase efficiency at a level we haven't seen before. And while right now they aren't used for primary diagnosis, that probably will happen in the near future. This could be a huge benefit to patient care. Just imagine being able to provide a diagnosis 13 times faster and with better accuracy. This could be the future of our field, so it's best to start preparing for it now. As always, I'll have links in the show notes to everything that we talked about today. Don't forget, you can follow the show on Twitter and Instagram. I'm at People of Path, or just connect with me on LinkedIn. Thank you for continuing to share the show with others. Together, let's inspire the next generation of pathologists and laboratory professionals. This show is a member of Health Podcast Network. Thanks for listening. I'm Dennis Strank, and I'll talk to you next time on the People of Pathology podcast.